Electrons acting like a perfect liquid in graphene. Think traffic turning into synchronized swimmers. No crashes, no jams. We'll break down what the Dirac fluid is, why it shatters a century-old rule of physics, and how it could rewrite sensors, chips, and even our understanding of the universe. From lab benches to black holes, let's dive into this weird, beautiful future of frictionless electrons. What's going on here, John?
Yeah, this is crazy. So they've essentially achieved something that sounds impossible, where they made graphene break a fundamental law of physics that's held true for over 200 years, or almost 200 years. So the Wiedemann-Franz law states that in metals, electric conductivity and thermal conductivity, which is how well materials conduct electricity versus heat, they always rise and fall together. So like two dancers moving in sync. But in ultra-clean graphene samples, researchers have discovered the exact opposite. So as electrical conductivity increased, thermal conductivity decreased and vice versa. This violation was dramatic and more than 200 times larger than the law predicted. So the breakthrough occurred at graphene's Dirac point, which is a special electronic state where the material is neither a metal nor an insulator. And so electrons at this point stop behaving as individual particles. Instead, they flow together like a nearly perfect liquid, which is 100 times less viscous than water, and resembles the exotic Quark-Gluon plasma, which is created in particle accelerators. So what's crazy about this is this just doesn't rewrite physics textbooks. It opens up new possibilities for, wait for it, quantum sensors, and provides a tabletop window into extreme physics, usually reserved for black holes and cosmic phenomena. So this is nuts. This is great for electronics. This is great for electricity. This is great for everything. But what are your thoughts on this, Craig? Do you think this is a pie in the sky, or do you think this is this is legit?
I think it's legit. It's cool to, like, every time we talk about graphene, something new comes out. You know, science just described this behavior as similar to Quark-Gluon plasma, the type of plasma that only exists in extreme conditions, like inside particle accelerators or the core of stars. Finding similar behavior in graphene at room conditions is remarkable. It shows that heat and electricity can decouple, defying the usual, like you said, Wiedemann-Franz law by 200 times, and opens a new hydrodynamic regime for electronics, design devices by steering electron fluids, not particles. So we could start seeing this in biosensors that detect molecules or nerve level signals, magnetometers that work indoors and off-grid without GVS for navigation, computing energy, cooler chips with ultra-efficient power electronics, better thermal management, and tabletop experiments for science that mimic extreme cosmic physics. So this it's opening up a whole new world for us.
Yeah, it is. And so this establishes graphene as kind of a platform for studying quantum critical phenomena, which typically requires extreme conditions like those found, like you said, in neutron stars and black hole events. So the ability to access these strongly coupled quantum critical behavior at relatively accessible laboratory conditions, it opens up avenues for testing theoretical predictions from string theory, holographic duality, quantum field theory, and a whole bunch more. So it also suggests that the condensed matter experiments could provide insights into fundamental particle physics and cosmology. So I know this is, again, getting high up there, but as far as technical goes, but this is really cool. I've always loved graphene as a material. I think it's that, and carbon nanotubes are our future for a lot of things, and this just proves it, or helps improve.
So this could revolutionize things like computer processors that don't generate any heat, power transmission lines with zero loss, electronic devices that work at quantum speeds, and thermal management systems with perfect control. Like, it opens up a whole lot of things. And beyond the practical implications, discovery connects tabletop experiments to cosmic phenomenon. So researchers can now study entanglement, entropy using graphene samples, black hole thermodynamics in laboratory conditions, quantum phase transitions at room temperature, and high energy physics phenomena without particle accelerators. So this really is a game changer on many levels. And according to my researchers, we're going to see early lab prototypes now, early specialized sensor measurement gear in 3 to 6 years, and consumer facing wins through thermal management or low loss electronics later in the decade.
Yeah.
So let us know what you think. As we're coming close to the end of the time here, we'd love to get your feedback on this. Is this going to change electronics, physics in the future as we know it? From smashing the Wiedemann-Franz law to channeling Quark-Gluon plasma vibes, graphene's Dirac fluid is more than a curiosity. It's a blueprint. Expect ultra-sensitive sensors, cool electronics, and new tabletop cosmology. Keep your eyes on materials, plus device physics collabs, because the next decade of quantum practical tech may flow straight through graphene. We'd love to hear your feedback. What do you got going on, John?
Oh, just working away, helping companies secure government funding. Maybe heading to a couple events. Not sure what's coming up. So this will probably come out after Elevate.
Yeah.
So Elevate probably would have been a great time. But yeah, how about you, Craig? What do you have?
So assuming this is November, we got a Flowgrammer event and a Toronto Startup Investor Drinks. If you're in the GTA area and want to learn or be part of a Flowgrammer, N8N, or Vibe Coding meetup group, join us. Go to flowgrammer.ca and check out the upcoming events and join us. If you want to find out more about how to take your startup to the next level, head over to torontostarts.com. Our events there, Startup Investor Drinks. So we do monthly. It's open bar, open pitch. It's an intimate event, and the conversations are next level. So check all that out there, and we'll see you in the future. Anything else, John?
No, that's it.
So thanks, everyone, for listening. Don't forget to like and subscribe and leave a comment. We really appreciate it. Have a great one.